Hello everybody, how are you all? I hope so. You all are doing well and enjoying your quality time with your parents and your near one. Okay, I am back with the new video of the 10th class science subject. Okay, so today we are going to take the chapter from your NCERT book, that is the 10th chapter. Okay, and this is from physics. We already finished 2 chapters from biology, 1 chapter from chemistry by Kahar sir, and now we are going to start the new chapter from this NCERT book, that is the 10th one, light, the 2 most important phenomenon which is related with the light, that is reflection and refraction. Okay, just to facilitate the studies, we divided it into the 2 parts actually. Okay, so now in first part we are talking about, we are going to learn about the what is light, what is its nature. Okay, and we also learn about the image formation by the mirror only. Okay, the plane mirror, the concave mirror and the convex mirror. Clear? In the next session we will talk about the lenses, their image formation, mirror formula, and also this related facts about this one thing. Okay, so first of all, as you know that this physics is the branch of science which deals with the physical facts, dimension, its behavior, nature of the natural things. Okay, so here this natural facts, one of the most important fact, that is the light. Okay, so first we are going to define it. You are quite familiar with this light, but unfortunately we are unable to define it. Okay, so first we are going to start with the definition. So what is the definition? The light is a form of energy. Remember, what is light? Is a form of energy that enables us to see things. Without light you can't see anything. Clear? Then second thing, light starts from a source and bounces off objects which are perceived by our eyes, and our brain process the signals, okay, which eventually enables us to see. What is the mechanism of to see anything? First of all, a source of light is compulsory from which this light comes and struck that surface or object. Okay, when this light will struck or falls on it, then it will be bounces back. Clear? And after it bouncing, when this light ray will comes to you, then your this eyes or the sense organ, that is the which is responsible for the vision. Okay, it will receive these signals, it will convert it into the which one thing, that is the impulses. It will carry it to your brain. Okay, and brain will finally analyze and you are able to see the thing. So first of all, to see any object you needed a source of light. Clear? Now one more thing, what we said, light is a form of energy. Can you prove this one? How can you say that light is an energy? What is the energy? Right, you know that energy is nothing special, it is just the capacity to do work. Okay, so light is able to do work, just like you are able to cook food, you are able to perform the different facts, okay, which is related with this light energy, right? So that's why light is a form of energy. Now we are going to discuss the nature of light. Clear? So if we talk about the nature of the light, then it behaves like a ray. Okay, how can you prove this one thing, light is a travel in the form of a ray? Just by knowing the process of reflection. Okay, what happened when you throw a rubber ball on a hard surface? Okay, it will struck it and bouncing back to you, but with a certain angle of reflection. Okay, so similarly, if light ray falls on any shiny object which is opaque in nature, then it will bounces back. Okay, and during this one thing, it will follow certain rules of the laws of reflection of light, what we will discuss that. Okay, now one more thing, light always travel in a straight line. Okay, in your previous classes, just like that middle school section, 6th, 7th, 8th, you already learned that how to prove that light travels in a straight line. Okay, it is in the form of a ray. Okay, I think so you remember that experiment when you place these 3 cards with the help of upholders, and by making the hole in the middle of it, okay, and by making them a straight line, when you place one that the enlightened candle one side, and when you observe from the other side, then you are able to see this light ray because it passes straight one. And if you just move the center card from this straight line, then you are unable to see the light because the light is unable to move like this zigzag way. Okay, so that's why light is always, what is its nature? It is in the form of a ray. Okay, then you can also say that light is always travel in the form of the waves. Okay, this interference in the diffraction of the light is a great evidence in support of this one thing. Okay, what is the meaning of interference? Likewise, you know that if the two light ray with the same wavelength, when exactly impose each other, okay, in 9th class you learn about the wave. Okay, here you can see the trough and the crest. Okay, crest and the trough is there. Okay, so if the two different light rays is taken and when they exactly impose each other, that means crest with crest and the trough with the trough, then you will observe that it will greatly emphasize its impact. So surely they are in the form of the wave. It is a great evidence in support of this one thing. Then we come to know that light is in the form of the particulate structure. Okay, light is in the form of the particles. And how can you prove that? By the photoelectric effect. How this photoelectric effect can be confirmed? When the light is falls on any metallic surface, okay, that is responsible to immersing out the electrons. Okay, that is in the form of the photoelectric wave. Okay, so this is the example to confirm that this one thing. Okay, then now here we are also going to learn about the speed of the light. Clear? So sorry, speed of the light c can be lambda into mu. Here what is this lambda? This is the wavelength, and what is the mu? This is the frequency. So when you multiply the particular light, you know the monochromatic light, no? The different monochromatic light will have the different wavelengths. Clear? But in all, when you talk about the simple beam of light, then it is nearly 2.998 into 10 to the power 8 meter per second, or 3 into 10 to the power 8 meter per second, when we are talking about in the most rarest medium. Okay, or when we are talking about the which one thing? That is the vacuum. Okay, so this is the basic fact. Okay, so this is the speed of light. Just remember about this one thing, and the definition and its nature also. Now here we are going to discuss that when the light incident on the another medium, then what happened? Clear? So there are the three possibilities. One, either it will absorb completely. Okay, second, if that surface is quite shiny in nature, okay, then it will bounces back. Okay, that is the reflection. Then it passes through or bends. When that surface is what type in nature? Transparent, then it will be bends. Okay, later we will discuss this phenomenon of the refraction of light. Okay, when the light move from one medium to another medium, okay, then it will bend from it the straight path. Okay, either towards the normal or away from the normal. That is on the basis of the nature of the medium. Clear? So this is the refraction. Okay, so when light is incident on a plane mirror, most of it gets reflected, you know that. Okay, and some of it gets absorbed in the medium also. Okay, so this is in general what happened when the light falls on a surface or when it passes from the medium. So here we are going to discuss the reflection of light. Clear? So the phenomenon of bouncing back of light rays in the same medium on striking a smooth surface is called reflection of light. Okay, as I told you, what happened when you throw a ball on the wall, then it will bounces back. Similarly, what happened when you throw a light, suppose that you are having a source of light that is in the form of the torch, okay, on a plane mirror, then by what angle it struck on that surface, it will reflect it back with the equal angle of this incident ray. Okay, so here we are also going to discuss this one thing. So on the basis of the nature of the surface and bouncing back the light ray, it is of two types. One, that is the regular reflection, and second is the irregular reflection. So what is the regular reflection? It is the reflection from a smooth surface, such as the light rays are evenly parallel to each other and an image is formed. Just like that, the reflection from the smooth surface of the calm lake can produce an image in water. Okay, so the very simplest example, you are quite familiar with this one thing. When you stand in front of a plane mirror, then you got the same thing. Clear? Now, so for the regular reflection, what is the basic need? The basic need of regular reflection is a smooth and plain surface. It should be 100% reflectory. Clear? Second one, irregular reflection. It is the diffused reflection from uneven surface such that the light rays are not parallel to each other and do not form an image. Okay, just like that, the reflection of light from the surface of a flowing stream and does not form an image. Clear? So this is the reason behind this regular and irregular. What is the basic fact? The parallel beam of light is received and reflected back. The same ratio of the angle. Here, even though it receives the plane beam of light, but when it reflected, then it will just varies from its angle of reflection. Just like that. Here the two diagrams are given. This is with the smooth surface and this is with the rough surface. Okay, here you can see that a beam of light where these three light rays comes parallel to each other. When they struck the surface, then again they bounces back with the same parallel nature. Okay, so this is the regular reflection. Suppose that if this point of incident is drawn with the help of a normal, that means a perpendicular is drawn here, then you will observe that the angle of incidence will be equal to the angle of reflection. Then it will be considered as the regular reflection and the plane beam of light will remain plane as it is. But in this one, what happened? When this plane beam of light will struck this surface, but because of unevenness of this one thing, even though it will follow the laws of reflection of light, the angle of reflection will be same as the angle of incidence. But because of this uneven surface, the direction of the bouncing back will be changed. So you cannot obtain the reflected rays as a composed form. That's why this is called as the diffuse reflection, or it is called as the which reflection? Irregular reflection. Remember this one thing. So what is the basic compulsion? It needed a smooth and straight reflective surface, and here it needed an uneven surface of it. Clear? Now then here we are going to learn the laws of reflection of light. Actually there are two laws of reflection of light. Clear? What is the first law? The incident ray, the reflected ray and the normal to the surface of the mirror all lies in the same plane. Okay, if you saw this diagram, okay, then what is this? This is the plane reflected surface. Here it is shade is there, that's why it is the symbolic form of the mirror. Okay, that means it is a pure reflected surface. Clear? So when an incident ray falls on it, so this ray is called as incident ray. Okay, this point is called as point of incidence. Okay, and this perpendicular when drawn on it is called as the normal. Okay, and the angle which made by this normal and incident ray, this is called as angle of incidence. Okay, so when it falls on it, then it will bouncing back in the same medium, but here it will form the next angle along with this normal. So now this ray is called as reflected ray, this normal, and the angle which made there, that is called the angle of reflection. Clear? So what is the first law? The incident ray, the reflected ray and the normal to the surface of the mirror all lies in the same plane. Okay, and what is the second law of reflection of light? The angle of incidence is always equal to the angle of reflection. Remember, this angle I is equal to angle R. Whenever you find the reflection, then it will always follow the laws of reflection of light. Okay, always angle of incidence will be equal to the angle of reflection. Clear? Now then here we are going to talk about the next most important phenomenon of the light, that is the image and the image formation. So first of all, what is the light? Clear? Sorry, what is the image? So if light rays coming from a point after reflection meets at another point or appear to meet at another point, then the second point is called the image of the first point. Remember, what is the basic fact? The light ray coming from not the source of light, from where? The point of the reflection. Clear? Suppose that this is the reflected surface when light falls on it, okay, and when you observe from this one, then it seems to be arises from this one, okay, and it another point of appear to meet, and it seems that they are meeting that this side or behind this one thing, then this one is called as the image of the first point, okay. So you will got the image of the first point. Clear? So the point where all the reflected light rays converges is known as the image point. Clear? After the reflection of light, they will intersect each other, okay. So this intersected rays meet at one point, and this point is called as image point, where you will get the image. And not only is it the point where light rays converge, it is also the point where reflected light rays appear to and observed to be diverging from, okay, from where they will further diverges. That means diverging means what? Moving away from each other, okay. And the image location is the location where the reflected light appears to diverge from. That means that point of intersection where these two different reflected rays are intersecting. So this point of intersection of the reflected ray is called as point of image or image point, and this side, this location is considered the image location from where this light rays appears to diverges, okay. Now on the basis of the nature of the image, it is of two types. One is the real image and second is the virtual image, okay. So what is the real image? If the light rays coming from a point actually meet after reflection, then the image form is called as the real image. What is the basic fact? The light rays coming from a point actually meet after reflection, okay, then this image is considered as the real image. And what is the virtual image? Virtual means false, okay, which is believed to be like that. Clear? So if the light rays coming from a point after reflection does not meet actually but appears to meet at another point, then the image form is called as the virtual image, okay. Basically especially this which one thing, convex mirror, okay, and the this one which one thing, plane mirror, this form actually the virtual image, okay. So here it seems to appear but it is not actually intersect or meet each other, okay. So this is the virtual image. Clear? So here with the help of this table we can consider what is the real and the virtual image. If you consider this point, that is the characteristics of real image, these are the characteristics of virtual image, and when you compare them, then it will be the differences between the real and virtual image, okay. So what is it? A real image is formed due to actual intersection of the reflected rays. So what is the first condition for the real image? The two or more than two reflected rays must intersect each other, okay. While virtual image is what? A virtual image is formed when the reflected rays meet if they are produced backward, okay. In front of the mirror they will not intersect, but if you want to intersect them, then you need to propagate or you need to extend backside the reflective surface where they will appears to meet. Clear? Now then, a real image can be obtained on a screen, remember, while a virtual image cannot obtain on a screen because real image is always formed in front of the mirror while virtual image is formed where? Behind the mirror, okay. Now a real image is inverted with respect to the object. Clear? Just like that, this is the object, then this will be the image. Clear? Now while virtual image is erect with respect to the object. If the object is like that, then the image will also form straighten, okay. Now the image of a, if you take the example, then the real image is the image of a distant object formed by a concave mirror, okay. While here the image formed by the convex mirror or a plane mirror, then it is the virtual image. So remember, this is the differences as well as the characteristics of the real and virtual image, right? Now Then here we are going to talk about the next important feature, that is the mirror. So what is the mirror? Mirror is a polished surface which is the glass and which reflects almost all the light incident on it. Clear? A shiny surface, okay, which made by the polishing glass from the other side. Okay, then mirrors are of two types. Clear? One is plane mirror and second is spherical mirror. Clear? So what is the plane mirror? Any flat and polished surface that has almost no irregularities on its surface that reflect light is called as the plane mirror. Okay, so remember this fact, it should be plane. Okay, no irregularities on the surface of reflection, that will be considered the plane mirror. Okay, when you want to form the image by the plane mirror, then what will be the feature? The image formed by a plane mirror is always virtual and erect. Just we learned in the previous discussion. What is this one thing? In the previous point, the virtual image is always erect. Okay. Now, second thing, the object and image are equidistant from the mirror. Have you ever observed yourself in a, that is the mirror? Okay. When you stand in front of a dressing table, okay, or the almirah's mirror, then you observe yourself. Okay, when you come close to the mirror, then you observe that the image will also come close to you. When you goes back, the image will also goes back. Clear? So this is because of this equidistant. Okay, object and image is equidistant from the mirror. Okay, so the size of image is equal to the size of the object. Clear? When you goes back, that means the distance between the object and mirror will increases, then surely the image of the object will also become shorter because it goes back. Okay, now then the image is laterally inverted, that means the left seem to be right and right seem to be the left. Okay, it is very common feature. I think so you observe that when you lift your left hand, then in the image it seems that there is the right, the image is raising the right hand. Clear? It is called as the lateral inversion. Clear? Remember this feature. Okay, it is very common. If you say someone that, okay, just by showing your hand, okay, you are having something here, then surely that fellow will scratch his or her left side. Okay, so this is the lateral inversion. That is the common feature of the which one thing? The image formed by the plane mirror. Okay, so if we want to learn about the formation of the image by a plane mirror, then this diagram will explain you very clearly what is the characteristic feature of the image formation by the plane mirror. One thing, that is the virtual and erect, that means surely it will form behind the mirror. The reflected ray will not intersect in front of the mirror, right? Third one thing, it is equal in the size of the object. Clear? So just consider this all points and then observe this diagram. Okay, see that this is a plane mirror. Clear? You can see that this is the object and this is the distance between the mirror and the object. Clear? Just take the two light rays which is emerging from this one thing. Clear? So these two rays are considered as the incident ray. Clear? They will falls on this mirror on the point A and C. Clear? So this 2 point will consider the point of incidence. Okay, just draw a normal on this point A and C. So here you will find that this is the angle of incidence and this is the second angle of incidence. Clear? So by following the law of reflection of light, it will be reflected back. When it will reflect it, then it will form this one thing. Okay, but what happened? It will goes away from this one thing, so there is no chance of intersecting in front of the mirror. Okay, so what is the second condition? Second condition, you have to just enlarge it. Okay, you have to extend it. So when you extend this two light rays, then here you will observe that that will be intersecting. Clear? So this point is called as the image point. Clear? The image will form where? Here, and this is the distance between the the mirror and the image. Okay, so it will fulfill all the aspect of the plane mirror image. Okay, this distance is equal to this distance. The size of the object and image is equal, and one more fact, that is it is erect in nature, okay. And one more thing, because it formed behind the mirror, so you cannot obtain it on a screen, okay. So this is the basic fact about the image formation by the plane mirror. Now we are going to discuss about the uses of the plane mirror, okay. So plane mirror are commonly used as the looking glass, okay, because the image is always erect and virtual invertedly. I told you in the almirah's mirror as well as the dressing table mirror, okay. Used in making the periscope, which is used in submarines to take the location and the picture of the object above the water surface, okay. Then the uses as blind turns of some busy roads to see the vehicles coming from the other side, okay. Just like that, L-shaped road is there, it goes like this one, so the vehicle which is coming from this is unable to see the vehicle coming from this side. So if you place one mirror exactly at a 45-degree here, then when this which one thing vehicle will come, then it will give the exact image this side, okay. So by following the law of reflection of light, we can obtain the image and we can easily identify it, okay. So there are used to make the kaleidoscope, okay. I think so this is the toy, okay. I hope so you are familiar with this one, no? A triangular shaped structure is formed by placing these three plane mirror strip by covering with the paper or this one thing, okay, and by inserting some colorful cutting papers or the pieces of bangles or somewhat, you know, and when you turn like this one, that will give such a beautiful pattern of this pieces, okay. So that is the kaleidoscope. Now here we are going to discuss about the spherical mirror. When the surface is quite spherical or curved in nature, then we call it the spherical mirror, okay. So consider a hollow sphere, just like a rubber ball, it is a hollow in nature, with a very smooth and polished inside surface and outer surface with a coating of mercury, so that no light can come out, okay. Then if we cut a thin slice out of the shell, we get a curved mirror, which is called as the spherical mirror. Very simple, just take a spherical ball, glass ball, okay, and then just polish it from outside, okay, and then cut a slice of it. Then whatever the surface which you got, it is the which mirror? Spherical mirror. But the condition is that either covered it from outside or inside, okay. So if the reflecting surface of the mirror is curved inward or outward, then the mirror is called the spherical mirror. It is of two types. You are familiar with this one thing, the concave mirror and the convex mirror, right? Now here we are talking about the concave mirrors. Clear? You can see that this is a spherical surface, okay. The hard surface which is polished from outside. So this painted or this shaded surface is used to reflect. That means the inner surface is used to reflect. That is called as the concave mirror. Remember, if a hollow sphere is cut into parts and the outer surface of the cut part is painted, okay, from where? Outside. Clear? Then it becomes a mirror, okay, with its inner surface at the reflecting surface. So which is the reflecting surface? The inner surface, okay. And this kind of mirror is called as the concave mirror. Remember about this one thing, the light converges at a point when it strikes and reflected back from the reflecting surface. So that's why this concave mirror is called as converging mirror, okay. And next one thing, the image formed by the concave mirror is always small when it is real, and at only one point it will form the virtual image, okay. So basically, what are the basic facts which we learn? Its outer surface is coated with the shiny like the mercury, okay. Its inner surface is used to reflect. Clear? Next one thing, this mirror is converging. Mostly it will form the smaller and the real image. Rarely, when later we will discuss, when the object is placed between the pole and the focus, that will form the erect, enlarged and the virtual image, okay. So now we are moving forward toward the convex mirror, okay. Now in this convex mirror, if you observe, just opposite the concave mirror, what you observe? In the concave mirror we polish from outside. Now, okay, now we are moving forward toward the convex mirror. Okay, just opposite of the concave mirror. Here you can see that the inner part of this curved surface is painted with the silver or that mercury. Okay, and this outer surface is used to reflect the light. Clear? What was the property of the image formation by the concave mirror? It was small, short term. Okay, real. Now here it will be the just opposite. Which one thing? It will be enlarged. Next one thing, sorry, not enlarged, but it is virtual in nature. Okay. Second thing, it cannot be obtained on the screen. Clear? Third one thing, this mirror is also considered the diverging in nature. Okay. So the virtual, erect and the diminished images are always formed with the convex mirror. Okay. And the irrespective of the distance between the objects and the mirror. And apart from the other applications, the convex mirror is mostly used as a rear view mirror in the vehicles. You are familiar with this one. Okay, you can see that the image which observe in a rear view mirror, okay, it is quite small. A big burst can be observed in a small mirror. Okay, it is only because of that is a diminishing image. This image become very small in nature, but it is virtual. That's why it is erect. So you can see strain, but here is again the inversion is observed. Clear? Now, then here we are going to discuss the important terms related to spherical mirror. So first of all, that is the pole. Okay. First of all, just consider this two diagram. Okay, see that these are the spherical surfaces. Okay, it used to cut here. It is polished from outside. This is polished from inner side. Okay, so this is a convex mirror. This is a concave mirror. Clear? This is the center of curvature. Okay, so just remember this one thing. Here P is denoted for pole. C is denoted for the center of curvature. This distance is considered as the which one thing? Radius. Okay, and this axis who is responsible to connect the pole and the center, that is called as the principal axis. Clear? So just one by one, what is the pole? The midpoint of reflecting surface spherical mirror is shown by the pole. Okay, so this is the spherical mirror. When you take this point as the middle of this mirror, that is considered as the pole. Okay. Now second thing, what is center of curvature? The center of the sphere that the spherical mirror was a part of it, marked by C. Clear? That means what? What is the center of curvature? The center of curvature is actually the center of such sphere. Okay, remember, it is the center of such sphere that the spherical mirror was a part of it. Clear? That is denoted by C. Then the radius of curvature, simply the distance between the pole and the center of curvature, that is called as radius. Okay, it is just half of the diameter of the sphere. Okay, and what is the principal axis? The straight line who connect the pole and the center of curvature, that is called as the principal axis. Then the focus. Okay, a point on the principal axis where the parallel light rays with the principal axis after get intersecting the principal axis, that is called as the focus. And remember, what is the focal length? The distance between the pole and the focus is called as the focal length. And always remember a relation between the radius and the focal length. Focal length is always half of the radius, and radius is always double the focal length. Clear? Then the aperture, the diameter of the reflecting surface of a spherical mirror, it is called as the aperture, as a part of the reflecting surface of a mirror which is exposed to the incident light. So with the help of this two diagram, you can learn about all these features with the convex and the concave mirror. Remember, center of curvature, pole, the distance between these two is the radius. Okay, the point where light is after reflection will meet, that is the focus. Clear? This much surface, this is the M and N. This one is exposed to the light, that's why it is called as the aperture. Okay, remember this few facts about this two mirror. Now then here we are going to discuss the rules of ray diagram for the representation of the image form. Okay, for the formation of the image, few facts are compulsory. Okay, so with the help of these two diagram, one for convex and one for concave mirror, we can learn this one thing. Okay, so for the formation of the image by a spherical mirror, you surely needed at least two light rays. Remember, at least two light rays. Clear? So here we should learn few facts. If a light ray is taking parallel to the principal axis, remember, if a light ray which is parallel to the principal axis, after striking the concave or convex surface, it appears to passes from the focus. Okay, remember this one thing. It will also follow the laws of reflection of light. Clear? Here it is intersecting the focus, and here it seems to intersecting when we extend it backside. Clear? Then second one, when a light ray is passes to the center and it just struck the concave surface, then what will the angle of incidence? If angle of incidence will be 0, then what will be the angle of reflection? It is also 0. So that's why the path of incident and reflected ray will be same. There is no dispersion, no deviation will observe. Okay, now here when a light ray which is oblique in nature, if directly struck the pole, then by following the laws of reflection of light, it will be reflected back. Suppose that this principal axis is also a incident ray. Okay, it is also falling on the pole, so it is also reflected with the same one. Okay, next one thing, if a light ray which is passing from the focus, okay, and striking the curved surface, then it will reflected back in the form of the parallel light ray. Okay, so these are the basic facts you should remember while forming the ray diagrams. Okay, so now here we are going to discuss the image formation by the concave mirror. Okay, so here in this tabular form you can learn this one thing. Okay, just I am telling you, this is the principal axis, this is the curved surface which is a concave surface. Okay, here this is the center. C stand for center of the curvature, F stand for the focus of the mirror. Okay, now here first we are taking what is the position of the object. It is at infinity. Okay, whenever the light come from the infinity, then it is always be parallel to each other. When this parallel light ray falls on it, then the image will form on the focus. Okay, as you know that when the light ray come parallel to the principal axis, then after striking back it will falls on the focus. Okay, so remember this one. Now then here what will be, the image is real, inverted and diminished in nature. Now next, behind the center but not at infinity, at a certain distance. Clear? Then you will observe that we are taking the two light ray, one parallel to the principal axis and second is passing to the focus. This parallel light ray will travel through the focus and it will become parallel, and here you may find it intersection in front of the mirror, in between the focus and center. So what you observe, the image is inverted. Okay, it is in front of the mirror, forming by the intersection of the two light rays. So that's what will be the nature. It will be real, it is smaller. Okay, and you can opt it on a screen. Now third point which we are taking here, you can see that the object is placed exactly on the center of the curvature. Okay, so what do you observe, the image is also formed where, on the same point. Clear? But what is the basic feature? It is real, it is inverted and it is equal in nature. Okay, so these 3 points. Now here we are going to discuss the further 3. When the object is placed between the center of curvature and the focus, then you can see that the image is forming where, behind the focus. Okay, one thing which you can conclude very easily, as the object come close to the mirror, the image is going away from the mirror and it is also increasing in the size also. Clear? Now, so what is this? The image is inverted and magnified in nature. Okay, now in this case, if object is exactly placed on the focus, then the image will form at the infinity. okay, it is upright, okay, and the reflected rays will be parallel. Now the most important diagram, so many times it asks in the final exams too to draw this one, okay. What you observe here, the object is placed between the focus and the pole, okay. So what you observe, the image will form behind the mirror, okay. Second thing, it is erect, it is enlarged, okay. So you know that this property is used especially where in a saloons, hair cutting saloon, and the mirror of the vanity box or your father's shaving mirror. If you observe, even this dentist also use this property to observe the enlarged image of the teeth, okay. So this is the basic fact which we learn from this one thing, okay. Now here we are moving forward. What is the uses of this concave mirror, okay. As I told you, when the light ray come parallel to this one thing, so this torches is basically work with the same one, the searchlights, the vehicle headlights, okay. Then the concave mirror is also used in the shaving mirror, okay. It is also used by the dentist, okay. And the large concave mirror is used to concentrate the sunlight as a solar heater, furnaces, and this one thing, clear. Now we are moving to form the image by the convex mirror, okay. So here only two positions are there. One, when the object is placed at the infinity, okay. So when this come parallel to this one, then it will reflect it back, bouncing back in the same medium, but it will extend, it will diverges, okay. So it will not intersect in front of the mirror. So to obtain the image, you have to just extend back side, then you observe that it appears to be diverging from the focus, or it is intersecting at the focus. So what will be the nature of the image? The image will obtain where on the focus, it will be virtual, and it is extremely diminished in nature, okay. And the second one, whenever you kept in front of the mirror except then the infinity, then always you will get the image in between the focus and the pole of the mirror, remember. So you will place anywhere, it will form here only, clear. The image formation by the convex mirror. Now we are going to discuss the uses of the convex mirror, okay. So first of all, it is very commonly used as a rear view mirror in the vehicles, because always given an erect image which is wider field of view is given by this one thing, okay. And the big convex mirrors are used as shop security mirrors, okay. This property was actually asked this last year's question paper, okay, to solve the numerical problems and to know about the nature of the mirror. So please take care of this one thing, just make your concept very clear, okay. So these big convex mirrors are used at the shop, in the shop for the security mirror purpose. The shop owner can see and keep an eye on the customers to look for thieves and shoplifters among them, clear. So this all about the which one, that is the mirrors and the image formation by the plane mirror and the spherical mirror, okay. So thank you very much. Just learn and draw the diagram of the image formation. Surely in your final examination one question is there for the image formation by the concave or convex mirror. So wish you all the best, keep reading, okay. Thank you very much.